So I wish I could broadcast this here, but you guys can pretty much see. Who knows how to do dominoes? You all know how to do dominoes? You know the rules of dominoes. If you don't, in the manipulative online, it gives directions. So let's say we start with the 6-6, right? 6-6 can be like this or like that, doesn't matter. But what can go on a 6-6? Anybody tell me? Only sixes. So you find something that has a 6 on one side and you put it there. All right. Now I put a 6-2 there, so I got to find another domino that has a 2 on it. So I'm going to put a 2 on there, and the 2 I got has a 3 on the other side. So now I got to find one with 3. I go 3 empty, then I go empty 6, and then I go 6-5, and so on, etc. Now my key here is on the domino problem. I want to find, is it possible to put all the dominoes in a row? Are you sure about that?
Yes, sir. You can.
You can go to the
Yes, you can.
I know you do all this work. But why do you eat the
Well, what if we model this problem, okay? What if we model this problem, okay? What do we mean by model? Okay, what did Leonard Euler do with that problem for the bridge? He modeled the problem, didn't he? Okay? The bridge problem. Okay? Let me see, is it looking at the screen right there? Yeah, okay. Tell me if you can see me. Can you see me in it? All right, so let's talk about this for a second. First of all, on these dominoes, what's the edge and what's the vertex?
The vertex or the outside?
The edge is
The edges are the vertex? No, each dot is the vertex.
The edge of the board.
Okay, remember when we were defining the edges by the two vertexes it intersects?
The vertex of domino.
The two vertices that it spans between, it bridges between. So this is a domino that spans between the number 6 and the number 4, right?
Yeah.
So how many different vertices do we have in a double six thing? Okay, so let's talk about it.
2.
We got, let's go by doubles. Double 0, right? So we got a 0. We'll call that vertex 0. Okay? We got double 1, double 2, double 3, double 4, double 5, and double 6. How many vertices do we have?
6.
Count again.
7.
That's right. Got 7 because the 0 counts as one of them. So we have a total of 7. So what we have to find out is how many vertices do we have. So let's go in order. 0, 0. That's an edge from 0 to 0. That's a loop, right?
14.
How many edges does a 0 have now?
2.
Exactly. 0, 1, right? That's an edge from 0 to 1.
0, 2.
Exactly. 0 goes to 2, 0 goes to 3, 0 goes to 4, 5, and 6, right?
Okay, but what's one don't go to 2?
Huh?
Why one don't go to 2?
No, it has 8, right?
I'm just doing zeros first.
Oh, okay.
Now we're doing ones. There's a 1, 1, right?
Uh-huh.
Then 1 goes to 0, 1 goes to 2, 3, 4, 5, 6. We're just modeling, okay? We're modeling. Now I want you to think about this again. 2 goes to itself. We already got 2 going to 1 and 0. So 2 goes to 3, 4, 5, and 6. 3 goes to itself. And it already goes to 2, 1, and 0. So 4, 5, and 6. 4 goes to itself. It already goes to 3, 2, and 1, and 0. 5 and 6. To itself, 5, and then 6 to itself. Now, by this graph, this particular graph model of the domino situation, we can count the number of vertices that are edges that intersect each vertex. So let's look at 5. 1, 2, 3, 4, 5, 6, 7, 8. Even. How much you want to bet all the rest of them have 8? Try 6. 1, 2, 3, 4, 5, 6, 7, 8. So if we look at all 7 of the vertices and they're all even, what can we conjecture by what we just learned in that video?
Circuit.
So now we've just proven we know a circuit exists by the definition, the very definition of degrees. We just have to find it. Okay? Think you can handle that?
You pretty much did it for us.
No, I didn't. I told you that one exists. That's all I did.